Everyone, it's January. Well, it's supposed to be 12th, but it's already 13th. Man, I work a little bit too late, so everything kind of get pushed back. I read a paper which actually talk about almost exactly the same issue as ours, the one that I'm trying to write. And that paper was very good, very solid. And usually you try to do review, like related work, and you try to say that, okay, something is wrong or something is not good with that one, with all the papers you're going to put in your paper. But this one I couldn't find any angle to attack it. It's just good. I mean, granted, it's a different type. I mean, like, the things in that paper is not exactly the same as the thing that we do, but there's a lot of similarities. But the most important thing is they use a very smart way to handle the thing that we actually just kind of sidestepped. But I don't know, man. This is not easy. All right, anyway. So we're late, so maybe I only do one instead of doing more than one. Ooh, I've done this before. Yeah, it's 2246. Like, what do you write now? 24. Yeah, I've done this before. You're given a tree, a connected tree, rooted at 0, consisting of n nodes numbered from 0 to n minus 1. Tree is represented by 0 indexed array parent of size n, where parent I is the parent of node I. Since node 0, oh, that's fine. You're also given a string s of length n, where si is the character assigned to node. Okay, return the length of the longest path, in the tree, such that no pair of adjacent nodes on the path have the same character assigned to them. So it will be A0, 1, 3, right? So that will be the one. How are you going to traverse then? You started from 0. Which one is the next one? Well, I guess it doesn't matter, because you can turn this into a thing, and we cannot go back, right? We cannot go back. So when you do it, so this is just going to be from 0 pointing to this, right? From 0 pointing to this. So that would be AB. It would be 2. Wait. It's 203. It's now starting from 0. Rooted at 0. I don't remember this one at all. Let me think. I mean, the longest path where they're different. And the thing is, you cannot go from 0. Because you go from 0, oh, yeah, hold on. Maybe all we need is them not be the same, right? So if you go from one node, and then you find the longest path, right? And then there could be another that lead to you, right? Because like in this one, I can say from 0, the longest path is 2. But I cannot just say, okay, what is from 3? Because that's not going to work. And we can do all the paths. Wait, hold on. All the paths, as you say. Maybe we can do all the paths. Because we know, right? So from each node, I can say, give me the longest path starting from this node. So right, we have every node we're starting from this node, we know. And then we can say, because this one I have a bunch of nodes, I have one with the longest, right? Then I say, give me the second longest, right? The second longest. So I just need to find the longest and the second longest starting from each node, because eventually we're going to have a path, right? No matter how the path can look like, it's always going to be starting from 1, right? And then going down, and then we can link this as a root, right? Going down some other one. So like a invert like this, right? Like this. So either is this, or we're gonna go up somewhere, down somewhere. All right, that's the only way to go. You cannot cross, so it's always gonna be either just down, right? Either just down, because you can't go down and go back, right? That's not allowed. Yeah, longest path in the tree. So it's a one path. So it's either from some root down to the children, or you go down. Yeah, you cannot go back, so they cannot come in. So the only way is you go down, and then maybe you go up. You go down and go up. What do you mean by you go down and go up? You cannot go down and go up because everyone only has one parent, right? So if you can go down, if you can go up, that one is actually just going down, right? Yeah, so eventually everything is just going to be one path down. Like this is just going to be this path, right? Start from 3, 0, 2. Doesn't matter. So we will find a path, but this path might be folded if we start from 0, right? Therefore, all we need to find is for each root of the subtree, we find the longest path starting from the subtree, and then among all its non-longest path, we find the second longest path, right? Basically, we just return all the paths, the length of all the paths that satisfy this adjacent kind of thing. And for this path is 0, and this path is 3, right? So this 3 plus 0. And then we'd be starting from here. So we just, okay, I think this will work. I hope it works. Then I can just end this. Yeah, and then I have to run yet another. Can you believe it? I need to do yet another tuning. Man, it is endless tuning. Endless tuning. I shouldn't turn off that one. Just endless tuning. All right, so what we're gonna do is we actually don't have to. Let me see, can we traverse this from bottom up? Because I know who is my parent. Huh. So we go from here, but now that's... I don't know, man. I don't know. We start from here, but then I need to know which one I connect to. Ah, this is the parent. I see. What do we need to do? So what we need to do is n. Well, we can do the same thing. Graph equals for this in range n. Now we can do n equals ln s. Okay, and then for ip in parent, enumerate parent. All right. So p, right? So if p, yeah, naturally we can say 1 to the n, and I'm going to start with 1, right? So we can say graph I dot append, no, graph p dot append I. Then let's say plain graph. Why did I do this? Because I'm not sure about the syntax. I just want to be sure. I just want to be sure. Nothing wrong with that. So I need a parent. So 0 will go to 1, 2. Okay. 1 go to 3, 4. 2 go to 5. 0 go to 1, 2, 3. Yep, that's right. Alright, so now we have, then we can do def dfs. We need an index. What else? We need an index. And then I think that's it, right? We're gonna return an int, the longest path. So for index. And we need to know if I don't have any children, then I should return 0, because this path is 0. This path is going to be 1. This is 2. 1, 2. Ooh. Length of the longest path 0, 1, 2. That's considered 3. So this one should be return 1, right? If not, graph index, which means it doesn't have children, return 1. Okay. If we have, then we say else lengths equals this. Including myself, right? Then we say for next in graph index if s next is not equal to the length is itself, right? So if it's not equal to, ooh, that's actually not right. That's actually not right. That's actually not right. Hold on. The longest length. That's fine. Wait, hold on. We need to know the longest length. Ooh, not just the longest length. It's the longest and the second longest length. So we need to return two things, the longest and the second longest. So let's see if we return a tuple. Longest and second longest. That's fine. That's just by myself. And then we say if this is not equal to s index, right? So these two are different. Then I can call dfs. So max len, second max len shall equal to dfs next, right? It's just from this, what's the longest, what's the second longest. That might not work. This will work. 1, 1. Every one is the longest and the second longest will start with a 1. Right? And now we just need to record the longest and the second longest. Then I don't need to return anything. Okay, I'm not returning anything. And then I need a result. We can do dfs. Oh, second longest should be 0. The longest Wait, hold on. So with this, the longest it should not be a second longest. Second longest should be 0. The longest is by myself. Second longest is nothing, right? Is nothing. So what I want is for each one, I find the longest and I find the second longest, and I add them together. So my children, right? Once we're done, which means for this, I find its longest, right? I only need its longest. Its longest is going to be, yeah, we only do this. We do this, right? And then we say dp index longest shall equal to maximum dp index be like this. If dp index, this is the longest, and the current longest should be myself plus dp next longest. If this is larger than this, then this shall equal to 1 plus dp next 0. That just return because we already done it, right? And then, oh, hold on, dp index 1 shall equal to dp index 0, because that becomes the largest, and then this one will become this, which means we can essentially do dp index 0 is equal to something like this, right? And now I update its second longest. But the second longest is including that. Second longest, holy crap. Oh, that's not gonna work. We shall start with 0. Both is gonna be 0, not including the thing. Both gonna be 0. Right, so both is gonna be 0. And then I just want a longest and second longest and then plus 1. That would be the result. But for me returning the longest starting from me going down, I don't need to recall the second longest. I just need to. This is so troublesome. What are we doing here? So each one, right? I have a bunch of my children. I just need to know all the longest starting from my child. I get an array, and now I return. I don't know why you're doing this, man. I don't think that's right. This is good. Return an integer. This is return 1, right? And then when I say rest is gonna be this, and that's nothing. And then I'll go through. If this is not different, so rest dot append this, right? We're going go through everything, and then we say rest dot sort. Okay, we'll sort it because I need the largest and the second largest. Okay, so after I sort, I say self dot res equals maximum self dot res minus 1 plus res minus 2, and I will return res minus 1 plus 1 plus myself. Otherwise it will just be 1, right? It might not have it. Okay, it might not have it. So res, so we shall say if res, right? If we have, so don't call it res, call it max child length, right? And then we say if this, we update, and then this is now going to be res max child length, max length, and then if not, I mean, I can just do this as 1, because at least you can do 1, right? If it's A and A, it will be 1, right? Is that correct? Is that correct? Like, say, if everything is exactly the same, the answer should be 1. Yep. So, if not, which means none of it, so I will be just returning 1. So with this, we'll return, else we'll just return 1, which just means if this, right? If this, we do all this, and if not, we return 1, okay? So then, what do? We do DFS, we start from 0, and then we return self.res. And we try to see if this one works, and it does not work, and we want to know why, because it doesn't have to. Makes sense, it does not have to. So if length, right, and then we shall say we shall always put a 0. Okay, if we always put a 0, then this one always works, and ooh, that's actually smart. So if this, we set it to 0, it's still not right, huh? Res, where do we have res? That's not res, that's max length. Right, as if we have 1. Oh, it's still there a situation where there's only 1. Then we put 2 zeros. Oh, we put 2 zeros. We put 2 zeros. If we put 2 zeros, we don't even have to check this. Right? If we put 2 zeros, even if it's the last one, this doesn't do, so this is 0, 0. So this will be 1, this will be 1. There we go. Just, 2 zeros. And I think we only use this once, right? So I can just say len s. I don't even need this. And we can do 0 here. It's okay. Okay, let's try this. Ooh, April. Okay, it's pretty bad. This looks like the last time. What went wrong? What's this? Expected 2. Got a 1. What's what's this one? 0, 1, 2. Right? 2 is 1, 1 is 0. We have A, B. So from 0, oh, you still have to go down. Damn it. You still have to go down. So you always, I have to, ML, L equals DFS. Yeah, that's my bad. And then if this, then you do L. You have to go anyway. Yep, that's the change. Oh, it's pretty bad, huh? Didn't realize. Yep, 27, 29. I'm pretty sure we are stuck on exactly the same situation. I need to take a look. That was the previous solution. This is this time. Should be the same. Yep. DFS. Oh, I use topological sort. Holy crap. This looks like exactly the same. P1, P2. Neighbor would do this if this. Yeah, just don't go this. I'll sort the whole thing. But they don't sort. They set up 2. Makes sense. Yep, it's almost exactly the same. What was this? I used topological sort? I have no clue what this one was. Yeah, I'm not even gonna take a look. So, yeah, we got this. Not that hard, huh? Good. So we can go to, we'll not go to bed yet, but we can, oh, they opened a solution. 2246. I'm glad that this solution was almost exactly the same as the one, as the updated one last time I encountered this problem in April 2022. Direct DFS, find DFS. The return of DFS index is the longest path that satisfies the question, starting from index. And for each index, we can also compute a potential result, which is the longest path starting from the longest path of its child plus the second longest path of its child plus 1, right? On, well, we actually have, so we have to say on log n. But actually, yeah, I'm gonna say on log n. But this can be, the log n can be simplified. Alright, we can just remove the log n. Use 2 variables to keep track the largest and second largest. So L1, L2, right? And this is L. Then we say if L is larger than L1, if L is larger than L1, it's max and second max. Right, if L larger than L1, then L2 equals L1, and L1 equals L. If L is larger than L2, then L2 equals L. Don't need this, and then this is going to be L1 plus L2 plus 1. And this will be 1 plus 1. Yep, this one we can probably say is ON. This will be exactly the same as last time we did it. Oh, look at the runtime. Okay, that'll be it for today. Half an hour, not too bad. We'll see you guys tomorrow. Adios.